The important gravitational forces in galaxy formation are thought to be those due to dark matter. To model the formation of galaxies, we don't have to know what the dark matter is, as long as we can put in its gravitational effect. In observations, visible matter acts as a tracer for what the dark matter is doing, but in simulations the dark matter is programmed in and can be displayed.
Okay, this shows a sphere of primordial material consisting of both gas and dark material that's separated off from the Hubble expansion and is about to collapse in itself to form 3 galaxies. As it collapses down, the initial noise in the system amplifies, and in the final big crunch and re-expansion, we get the nucleation of the central region of the first galaxy, showing in the green. And down at the bottom, a second galactic nucleus forms. And these long linear features then wrap up to form spiral arms, forming a spiral galaxy on the left and a barred spiral on the bottom. Top right, sections of subgalactic material merge to form an elliptical galaxy. So we end up with a spiral, elliptical, and a barred galaxy.
Using this simulation, we can also look at the dark matter on its own. The dark matter forms the bulk of the mass of the galaxy and so governs the whole process. To find out if galaxies are forming today, it's no use just watching a galaxy to see if it changes. It would take far too long, millions of years. So here's a more roundabout way. This is a simulation of the stage galaxies had reached when the universe was 1,000 million years old. It was created by George F. Statio at Oxford University. The biggest galaxies formed first, where the density concentrations were greatest. The big reddish blob contains large numbers of older, redder, low-mass stars. But lots of small galaxies also form at the same time with bluer, more massive stars which burn out quickly. There are many such blue galaxies in the simulation. But what about the real universe? Well, when we look deep into space at a redshift of z equals 1, which corresponds to the age used for the simulation, we do indeed see such small blue galaxies. So that suggests that the simulation is working well. And incidentally, looking at the current stage of the universe, that is at small redshifts, much less than 1, we do not see small blue galaxies, and this suggests that there are not galaxies forming nowadays. But notice that this is a very indirect way of getting to an answer, and it's not conclusive. Although we don't see galaxies in formation, what we do see quite often are clear signs of galaxies interacting. These interactions can to some extent rejuvenate the galaxies involved by prompting star formation from the remaining interstellar gas. In this simulation, produced at the Pittsburgh Supercomputing Center, some very realistic galactic shapes are generated. Compare the result of this simulation with a photograph of the antenna galaxy pair, which is in the constellation called Corvus. The resulting shape depends on just how glancing the encounter is, and the appearance to us depends on what angle of view we have. As the view rotates, we can see just how thin the galaxies really are. This simulation of a galaxy is realistic enough to have a hint of spiral arms caused by density waves. At the lower left of the screen, you can see a much smaller galaxy. Let's fire it in and see what happens. A galaxy is only just held together by gravity, and even this small intruder destroys its delicate structure.